be covering making our own virtual representation of a card. So we're going to do that via creating a card class. If you don't know what a class is, you can think of it as a struct sort of data type from the previous 2-3 videos ago. But mainly what makes them different than structs is that while they are made up of a collection of either primitive data types or just other classes. In this case, could have been structs. You can actually have a struct in the card as well. Not sure why you would want to rather, but it's fine. The thing that makes them sort of differentiated from structs is that classes also have methods. And if you want to know what a method is, it's sort of a self-referential function that pretty much only class has. I know that's a little bit confusing. Hopefully we can clear that up with a few examples. If you want, okay, yeah, so moving on, what does a card actually have? A card is made up of a number, generally between 2 and 13 to represent the cards up to the king. The ace can either be high or low. In Texas Hold'em, it is a high card, which is why 14 is going to represent our ace. They are also made up of suits, suits and colors. But if you think about it, a color is sort of represented, not represented, it's sort of, if you know the suit, you can get the color. So it's sort of, you don't actually have to include it. I mean, you could if you wanted to, but I'm not going to. Like if you remember, just on the very, very off chance you've never seen a deck of cards, they're split up into diamonds, hearts, clubs, and spades. What is a string, you ask? Didn't cover that earlier. If you recall, you have characters like C or H, but if you want to represent a list of characters as an actual name, it's sort of the double quotes name, like this. And you can represent an entire word of, it doesn't have to be a word, it's just a list of characters. And that'll work just fine. It's giving you an error message because it's just some little thing randomly in the code. So these are the data members of the cards, basic like this. In Java, there are also in class-based programming, there are monikers like private, public, and protected, which basically describe how you can access these little data members, excuse me. If they're private, they can only be accessed by this particular instance of a card. If they're public, they can be accessed pretty much anywhere. Protected is sort of in a hierarchical class structure that we're not going to get into because A, it doesn't suit this project, and B, it's a little bit more advanced. Not that much more advanced, but still it's something to be aware of. So once we have the data members, we are also going to create methods based off of them. So what methods do we have? Since these are private, we're going to need accessors. We're going to need constructors. What is a constructor? A constructor is basically how you create a little initializer for your card. If you remember, whenever you go int number equals a number, that's sort of what happens. You can't just say card A is equal to whatever. You have to actually give it some startup arguments. The startup arguments you give it are going to be obviously representative of some of its data types, some or all, depending on what you actually want. So if you have a card given, you can create it based off of a number and a suit. In this creation, we'll set number equal the card's number this equal to the number that was given. I know it's might be a little confusing because these two things have the same word, not the same. Sorry, not the same word, the same name, which is why this statement comes into play. It's a key word that lets sort of the program know, hey, this number over here refers to the card's number and not the argument from this. So you set the number equal to the number given and the suit equal to the suit given. Ta-da! We have our little initializer. It was pretty simple, wasn't it? But also because if you don't know these two, well, no. I'm gonna say, should we include setters or not? Might as well. We're probably not gonna use them, but they're good examples of why. If you have, public void. Sorry, it was giving me an error message, and I was like, what? But it's just because I didn't include sort of a data type. It sees these as functions, basically, and since it knows that set number isn't a class, like it is for this statement up here, it says, hey, you have to return something, which is why I included this void statement. It doesn't actually return anything. It's sort of an accessor. Void statements are, it basically means a return nothing function. They are used mainly for their side effects. In this instance, a side effect is given a card, it sets the card's number to a given number. So there you have it, which means we're going to just use this number equals number, and we're going to do the same thing for the suit. Public void set suit. String suit. Okay, so we're probably not going to use these because the way I'm thinking of it, we're just going to create the cards once and then move them around. Setters are generally used for if you create a class but you don't know what its data types are actually going to be. You can just sort of have them be placeholder values and then come back and set them later. In this case, we don't actually need to come back and set them later because we're always going to know what they are to start with. But in general, it's something you should think of. So there's like, I don't know, there's a little instance of, hey, don't include things you don't need in your project, but sometimes you don't exactly know what you will and you won't need. But moving on, we are also going to need getter functions. Getter functions, what are getter functions, you ask? It's to access the values of these data types. Since they're private, you can't get into them and access them from anywhere that you would want to access them from. So to sort of a little bit of a get around that, it's just this little getter right here. Get number. So it's saying, hey, return the number of this card. And in the same instance for the string. Ba-ba. Ta-da. And then sort of the final method for that would make up a card is going to be a two-string statement. What is a two-string statement? It's not actually a data type, believe it or not. Its data type is string. Two-string statements generally just refer, well, no, not generally, they are put into a lot of, and by a lot of, I mean you should put them into almost every Java class you make, and it's just sort of returns the values of the data members in these cards. Because say we don't want to actually access them, well, yeah, you could just do this right here to come and then combine them. But if it can be done in 2 steps and it can be done in 1 step, why wouldn't you just give them a little 1-step type of a situation? Like you just want to display the card. So we are going to right. Create a little temporary string that we are going to build our data types off of. It's just a little, it's initialized to nothing. And we know we're going to return it. So this is just saying, hey, it's empty at first, and we're going to add stuff to it. So we're going to go if this dot number is greater than 10, and then because if it's greater than 10, you're going to want to output Jack, Queen, King, Ace. Otherwise, well, started getting a little bit ahead of myself. Otherwise, temp plus equals this dot number. And if you recall, you can sort of characters and integers are interchangeable. It's sort of whenever you try and add an integer to a string, it says, okay, it must mean the actual number representation of this, of what's over here. So it's going to output the characters over to temp, which even includes it. If it is 10, it's going to say 10. It includes some multiple characters. This could be 104, and it would include 104 in temp. But anyway, so up here, unfortunately, we actually have to check the individual cases because they're different for each little thing. So if this dot number, I'm just going to copy this so I can paste it a little later. If this dot number double equal sign to see if the values are equal, because you can't use a single equal sign because that would set the number. If you refer to the single equal sign is an assignment operator, the double equal sign is a comparison operator, if you didn't know that already. So if this dot number, you get the number of this card, and if it's 11, I'm going to go temp plus equals Jack. And actually, I know I copied that earlier. We're going to copy this whole thing and just change the little individual values. Jack, Queen, King, Ace. 12, 13, 14. And I know, well, I don't know. You may be wondering why I didn't include brackets. Generally, brackets, you only actually have to have brackets if you are executing more than one statement in the little if statement or else statement. They are generally included just for a sort of, they make it a lot easier to read and tell what is exactly inside the loop for anyone picking it up. Hopefully, you'll just say, hey, I can recognize that it's not checking all of these at once. And I guess you can make the, theoretically, you're going to want to make these else-if statements. It doesn't really matter that much. It's just sort of checking. It's a conditional check, basically, I want to say. So it might help the compiler work around some things. It's getting a little too complex to actually know about it. Like, you don't have to worry about it. It's no big thing. But yeah. So that's why they're else ifs. Basically, is what I was trying to get at. Okay. So given these statements, we can now get a string representation of a card's individual number moniker, which is also replaced by its name for all of the face cards. So after this, you are always going to just want to, oh wait, yeah, never mind. I was going to say, oh wait, we need to add a space. So you could add the space either before the next thing or after the next thing. But just to make things clearer, right? You don't want them piled up on each other. So the other aspect of the card we're gonna have to add a temp is suit. So you just go temp plus equals this dot suit. Right? You understand that? Should be easy. And then return temp. So now we just wrote all of those little functions, and we're going to want to test to see them if it works. You don't want to, you sort of actually going into it, I might have wanted to test some of these functions earlier if you think about it. It's just sort of in the process of programming, you want to check often, because otherwise an error, like if you go too long without compiling and checking your code, and then you just get some generic error message, you'll be like, what? And you won't know exactly what's causing it. So theoretically, all of these should be good in this, well, keep double clicking over there, I can just single click up here. All of these statements should work out fine. So some testers, so we're going to say card example equals, well no, you just go card example and give it some values. So we're going to say, hey, it's 2 of spades, right? Oh, yeah, so you actually do have to do this. My mistake, been a little while. No, it's not. It's card example equals. I'm gonna find method example. So it's gotta be card then, right? I really want to say it was just sort of say card example. Can you just say card example equals card? Cannot find method card. So it's having trouble finding our constructor message. Obviously, this doesn't really reflect well on my ability as a programmer, but hopefully it'll help you interact with it, because this is the sort of things most people are going to run into. If we can't find our constructor, let's check over here. Public card, whatever. Sample equals. It looks really weird as a spelling of card if you ever examine it, but I'm pretty sure that's how you actually spell it. It'd be super embarrassing if it wasn't. But anyway, When in doubt, check the internet. Java classes initial, well, constructor right there. I was gonna say initializer or need class, but you just want this little example. New. I was forgetting the new keyword. My bad, folks. Been a little while. Mostly I've been programming in basic C, which doesn't have classes at all, and it's very good for systems programming. Applications programming, I guess you could argue that it could be good, but it's I don't know. I think it's much better for its systems programming aspects. But that's sort of not important right now. So we figured it out. That's what we were forgetting. This little new keyword. Remember that. Remember that, folks. One of the syntactic differences between Java and C++, I was going to say, is it doesn't have cout and cin functions as your simple input and output. Its output can be, well, no, I guess it's a print line. This system.out is so you don't actually have to import the files or whatever. It just automatically knows exactly where to get it. There's also system.in input statements that you have to create if you want to read in input. But our project doesn't actually do that, I think. It just sort of, well, I mean, I guess in the later stage it's going to read in for bids, but we're going to handle that with the GUI interface. So even then, it's not going to read it in directly. It's more of an implicit statement. But I digress. Yeah, so we just run this little program. It should output two. I didn't put the of for the suit, I guess. We might have to. It's just going to output 2 spades. Yeah, so we're going to include a little of because otherwise it makes it slightly confusing. So that should fix that. And then we also want to test our other functions, which would be the getters and setters. Again, setters are not really required in this project, but if we have them, might as well test them just as a little example case. So we're going to set number to 14. If you recall, 14 is the ace. And we're going to set number, well, no, set suit, rather. Sorry about that. Not, what? That's, sorry, I think it's sort of macros to common functions. If you see those little drop up boxes, rather. Not drop up, drop down. Silly me. But yeah, so there you go. So we set this to the ace of hearts. You know, system.out.println example dot get number plus of plus example dot get suit. Semicolon to end up the statement. And here you go. So we run this, and our expected output is it's going to say 2 of spades, like the original run, and then it's going to say ace of hearts. So we're going to see if our expected output matches up with the actual output. 14 of hearts. So half right. Oh, because yeah, this get number This probably should be a string, actually, shouldn't it? Huh. Well, if you think about it, you might want to get the number from the suit, or you might want to get the suit's um, like this. I keep getting muffled up. You might want to get the value as a number, or you might want to get the value as a string. So we're going to try and overload these functions. If you don't know what overloading means, it's that two functions that have the same name and they take the same arguments. But well, not that they take different arguments and get you different values. We can't do this. We're not going to be able to do this in this case, I don't think, because it's already defined, and you can't give it different arguments and overload it because it has no arguments. So yeah, we might want to just leave it. Yeah, actually, and we're going to want to leave it as just a number, because whenever you get this value to do anything, you don't want to have to convert it into the face card representation of it just to say, hey, is this are these both aces? Well, let's find out. Let's get their numbers, and then let's convert their numbers into strings, and then let's test those values. You can just test the numbers directly with the get numbers. So I guess this little statement is fine because it works as expected. Well, as you expect the function to work. It didn't work as I expected the entire output to work. That's what you call a logic error, which means the program is doing exactly what it's syntactically and semantically supposed to do. A logic error is with the programmer behind it saying, hey, you should add these instead of subtracting them, or in this case, you should get a number, but don't do anything with that number. You shouldn't convert that number into its face card representation. But anyway, there you have it. Step 1, get some cards. We have the possibility of creating cards. So next video we're probably going to make a deck and then shuffle it, because making a deck should be incredibly easy. Well, yeah, in my opinion, it's incredibly easy. It's going to cover a concept that I haven't brought up yet, but I'll bring it up in the next video. See you soon.